I just want to
11 days, bro. 11 days to what?
All right, so we talk about this. Shh. Anytime you have to think about the prior skills, so Rajesh is in right thinking. I don't know if he did the right math. No. Okay. Okay. So you gotta think about, why did I say telescope series usually have to break up to two fractions? Because usually like one subtract each other, they will actually cancel out all the middle term. And that's what the core part about telescope series. And so you have to make that happen. But right now we have one fractions. How do we make that happen? Right? So partial fractions, that's the best way. So decompose a fraction, or also known as a partial fraction, you can decompose this to what? What do you decompose as?
You get
Not 4 over 2n plus 1, no.
2 over minus 1 minus 2 over 2n plus 1.
You guys already forgot how to do partial fractions? Huh? You didn't know how what? You didn't know how to factor? Do you guys remember how to do partial fraction?
Yeah.
Okay, 4 over 2m plus 1 and 2m minus 1. And Aiden just told me he didn't know how to factor. And you multiply both sides and you plug in n equal to 1/2. You plug in n equal to 1/2 and negative 1/2. You solve for a and solve for b. And then once you solve for a and b, a should be equal to 2. B should be equal to 2 as well. Negative 2 actually. I don't need to teach you how to do partial fraction, right? You guys got it? Landon, you got it? Partial fraction? Vanessa? Isabel? You got it? Okay. She's locked in. Okay, Jing? Corbin? Ethan? Okay. So now we're gonna start plugging the value. So what I plug in the value? 2 over what? What is the first one? 2 over 1, right? Minus what? 2 over 3? And then plus, what's the next one? When n equal to 2, so it'll be 2 over 3, right? Minus what? 4 over 5. We're gonna do a few more terms. And then when n equal to 3, so it'll be 2 over 5. Wait, did I do something wrong? This is not 4, this is 2 over 5. I write it wrong. So 2 over 5. And then what's the other one? Yeah, 3. 2 over 7. I'll just do one more just in case. Plus, what happens next one? 2 over 7 minus 2 over 11. So if you see that little middle term here, they start canceling. So eventually you got 2 minus 2 over 2m plus 1. Because this is n equal to 1, right? This is n equal to 2. This is n equal to 3. This is n equal to 4.
So it is 2, right?
Yeah, it's just 2.
Yeah, Raj was right.
Yeah, so the answer is 2.
Hey, Mike? Oh my, it's wrong.
I didn't say it's wrong. They say his math is wrong. His partial fraction is wrong.
No, it's just the addition. Bro. Man, listen.
This is 9, sorry. My fault, this is 9. Sorry, that was 9. That was not 11. I counted wrong. All right. Shh. Does this make sense? Okay, so a long time ago, Algebra 2 used to teach this. Algebra 2 no longer teach this. It's called infinite geometric series. They actually teach this because that's actually one of the things that you can actually do. So we're gonna talk about geometric series. Shh. Okay, what is geometric series? Geometric series is gonna be like a summation of n equal to 0, infinity a to the r to the n. Or it's called common ratio. So let's just say this one's a. Your next term is going to be plus a to the r plus a to the r to the square plus a r to the third, and then dot 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 until a r to the n. A cannot equal to 0 because your first term equal to 0, then everything's going to go to 0. So a cannot equal to 0. That is one of the things.
Why does it start with n equals 0? So, I thought you can only have integers as the term.
N equal to 0 is what? 1. So that's how you get a.
But why? But I thought n could only be starting at 1.
You don't have to. You can start at 0. Sometimes you can start at 0. Sometimes you can start at 1. Sometimes you can start at 2. Really depends. It's how you label them. Okay, so do you guys remember like in your algebra 2 that there is an equation, that there is a series like this: 1 plus 2 plus 4 plus 8 plus 16 dot 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 dot, right? And that there is a way to calculate this. The formula looks like this one. Sorry, give me a second. Let me find it. The Sn is equal to a to the 1 minus r to the n over 1 minus r. I'll show you how to use it. Okay, so let's just say if I do the first 4 term, right? We know is what? Answer is what? 15? Okay, so let's try it. S to the 4th. This one's gonna be 1 minus r. What's r in this case? Do you guys know what's r? R is common ratio. Ratio is 2. So it'll be 2 to the 4th over 1 minus 2. What'd you get? It's a 15? So 1 minus 16 over negative 1. So it's equal to negative 15 over negative 1 is equal to 15. Guess what? First 4 term is what? 15. If you don't believe me, try the 5th term. 1 times 1 minus 2 to the 5th over 1 minus 2, right? What did I get 2? You take this term divided by this term. So that's called common ratio. So that's gonna be negative 31, I believe, over negative 1. So it's gonna be 31. Guess what? If you add 15 plus 16 is equal to 31, right? So that's how do you use this this type of this is called finite series, finite geometric series. So here's a question. This is a formula you can use for any finite term, long as you can figure out what the ratio is. If you figure out a ratio, then you can figure out what are the first 10 term or first 100 term. You should do that in algebra 2. Anybody done this in algebra 2? You did in pre-calc? With Kinch?
No. Oh, we did.
Okay. Yeah, possibly.
Oh, yeah, we did. We did arithmetic. We did geometric, but they were like a lot.
Okay, so so what we worry about right now, if we have, let's say, common ratio is 2. Anderson, put your phone away. Let's say your common ratio is 2. Your infinite series is gonna be what? If your common ratio is 2, what happened with your infinite series? No, what happened with your infinite series if you have a ratio of 2? Thank you. It goes to infinity. It's diverge. Okay, so here's the question. What does ratio need to be in order to be converged? Y is less than 1.
Because it eventually gets to 0.
Eventually it goes to 0. Now pay attention to this specific term, right? Pay attention to this specific term. So a times 1 minus r to the n over 1 minus r. Now imagine that this r is slightly less than 1. Slightly. It could be 0.9, or it could be very generous. It could be 1/2. But what happens if 1/2 to infinity power? Or 0.99 to infinity power? Would this term completely goes away? So that makes that the infinite series, it can be evaluated if it's an infinite series. For example, that there's gonna be, if the n's go to infinite, if n's go to infinite, then this part is gonna go 0. So s to the infinite is gonna be a over 1 minus r. Only when it's r less than 1. That's good, because that is a very good conclusion, because owning r is less than 1, you can be evaluated geometric series. Okay, yes.
Is the same thing if like your n is negative or your r is negative?
R can be negative, but actually its absolute value r has to be absolute value r has to be less than 1.
Another question.
You can have a negative.
If r is 1, is the answer
R, if it's r cannot equal to 1, because if r equal to 1, then it's just gonna keep on adding the same number.
it goes to infinity.
It's still gonna go to infinite. Has to be r has to be less than 1. Are you following me?
Yeah, that makes sense. If we're in series, can it start like n equals negative something or not?
No. You have the lowest you can start is n equal to 0. Yeah. Uh-huh. No, absolute value r has to be less than 1. So you can have negative 1/2. You can have a negative 1/2. Are you following me? So think about a pizza situations, right? What do we start out? We start with a 1 pizza, right?
Yeah. Man, I'm hungry.
So hold on. We start with sorry, we're gonna start with that says 1 plus 1/2 plus 1/4 plus 1/8 plus 116, right? And we keep on going. First of all, what's common ratio here? Right, common ratio is always this divided by this, and it has to be consistent. So double check couple terms to make sure they are geometric. Are you following me? So you check out every other term, you say, oh yeah, common ratio is equal to 1/2. So therefore, this is a geometric series. It has to be geometric series in order to use geometric series formula. So then we say, okay, well, what if this add to infinite? Well, the infinite start with a 1 over 1 minus r, right? So be 1 over 1/2, so the thing's going to be 2. So we know that this is going to add up to be 2. Why is 2? Because you start with a 1, and you then you added the half a pizza, half a pizza, half a pizza, so you end up to be 2.
A is our initial, right? So that's why we use 1.
Huh?
A is initial.
A is initial value. Okay, A is initial value. Got it? So if its R is greater than 1, this diverge. Make sure R is greater than 1 is not a question. It will just go to diverge. R equal to 1 too. Sorry, R equal to 1. So anytime that you hear R, absolute value R less than 1 is okay. So can you tell me what happened here? Summation of n equal to 0. Now this time you want to start n equal to 0, and infinite, and 3 to the 2n. So let me see if you know what will be the answer here. What? What is what? Would it be converge? I don't know. I'm asking you.
When he first put up the thing about A equals 1 minus r, what you would ask it question. No, I mean like
I'm sorry, I forgot to write down this formula for you just in case. We already sort of did, but n equal to 0, infinity a to the r to the n. It has to start with 0 and it's always equal to a equal to 1 over r, 1 minus r. And in converge, it's going to be like this. And this is the only way that's to be converged. Cannot equal to 0, but between 0 and 1. So you have to make sure that this is this, then we can use that. What did you guys get?
4.
4.
It's not 4. It's 6.
Wait, so n
Yeah, who can't do math now, bro?
I didn't know 8 times 1 is 8 times like n is negative.
So think about it. Your first term is going to be 3 times 1, right? Plus 3 times 1/2, right? Times 3 times 1/2 square, right? Are we okay here?
3 times 2.
Huh?
Basically just 3 times 2.
Well,
3 times 1 plus the
so you can rewrite this with summation of n equal to 0, infinity. You can write it like this. That's a better way to write it. Do you see that? That's 3 times 1/2 n, because only 1/2 is increase. It's only 1/2 is a ratio. So this is what you're gonna start with. This is a. So a is equal to 3 of 1 minus 1/2. So 3 over 1/2,
I'll be back from 81.
and that's equal to 6, right? Okay, so in here, they can also rewrite. Sometimes people says, hey, what if I start n equal to 1? N equal to 1 is going to be looking like this. It's still equal to the same thing, but you can start n equal to 1. So they both are fine.
What
If-
if you start n equals 0 of that?
N equal to 0 is this one.
N minus
No, but like you do start at n equals 0 and it's a r n minus 1.
No,
You can.
either this or this. So
Well,
either this
okay,
or
that would
this.
be like a different thing. Because that would mean that you have, yeah, it would be a different thing entirely.
Oh, yeah, it's for that rule.
Yeah.
Okay, you ready for the next one?
Yeah.
So what if I write a question says this? Sorry, this. No, let me rewrite this question. Sorry. Let me rewrite this question as summation of n equal to 1 infinity a to the n is equal to 5 over 3 minus 5 over 9 plus 5 over 27 minus 5 over 81. So this is summation. This is the things. Can you tell me that what happened if we reach infinity?
What?
Now be careful how I started. This is n equal to 1.
Is it a to the power of n or a?
Is it the same formula?
A n.
Or is it like this and there?
It's like
15 over 4.
Now remember, I start with this one. I start with the n equal to 1 here. So pay attention which formula I will be using and what will be your starting value and what will be your thing. Okay, so it is slightly different.
No, because this has to be the geometric. It has to be AR.
So it's like me ahead of this. Okay. A is 5 over 3. And then R is 1/3. So it's just 5.
Are you sure R is 1/3?
Don't do this to me because we oh, look at this flip thing, right?
You told Vincent to go back to your country? Vincent to go back to your country? That's crazy.
No, I'm saying you said like we're ready to then it's 5, what? Oh, wait, that's bad though. Because you get, it's 4 over 35, so it's 15 over 4.
no, bro, it's not that. Look at your first term, 5 over 3. That's your A is not 5.
Yeah, it's not limited. That's the
And then yeah, you wouldn't get 15 before.
Yeah, you get 5 over here. It's just
Yeah.
times.
Oh,
because it's still 3.
15 over
5
12.
over 3.
Yeah.
Yeah, okay, you're right. Okay, yeah, you're right.
What was it?
What?
All right. So what you get? 5 over 4 is correct. 5 over 2 is not correct.
Good face value.
So can I rewrite this in terms of this? So if we have summation n equal to 1, infinity, and the first term is a is a 5 over 3, right? Is that okay? What is r in here? How do you take this divided by this? Negative 1/3, and you take this divided by this is what? Negative 1/3, right? For each time. So it'll be negative 1/3 to the m minus 1. Because we use in the second one, right? We start n equal to 1. So then you can just say, oh yeah, that's equal to 5 1/3 minus 1 minus negative 1/3. So that's equal to 5 over 4. And that's equal to 4 over 5. Wait, so I can add 5 over 3. I can read my own handwriting, that's why. That's equal to 4 over 3.
Yeah.
And then this is gonna be 5 over 4, and that's the final answer, 5 over 4.
Yes. Let's over 4.
We could.
Okay, so I'll give you a tricky one.
You said you're just in time to do it.
You had to be really good with exponent rule on this situations. No, you don't have to ln, you dumbass. You're being stupid. How much time I have?
2 minutes.
Is it? Thanks, Kelvin, for lying to me.
I'm sorry that I'm wrong.
So R is E over
E over 3.
It's like this. E over E, and then oh yeah.
But you can't plug in.
Hold on.
That's not.
Hold on, my cousin.
Hello, my fellow.
Can I announce the answer?
No, whoa. Jello. What do you mean Jello? Bro, how do you simplify it? What are you doing? Why are you looking at me, bro?
Now I need to find out how to write
You can figure out Oh, it's
Yep, I'm this.
Yeah. He's a full 3 years.
All right, so the answer is E over 9 minus 3E. All right, so I want to make it into this formula right here. So that's n equal to 1, infinity. I'm going to break up this e to the n over 3 to the n times 1 over 3.
Oh, that's smart. Oh, I see what you did.
Exponent rule.
Yeah, that's smart.
Well, that's true.
Now, but the problem is that you got to think about it a bit. You wanted this to be, you want it to be e over 3 to the m minus 1. So what do I need to do?
Wait.
I want to make it at m minus 1. So what do I have to do?
Oh, I did 3 and 3 wrong.
What do I need to do? This is m minus 1, right? So that means this need an extra e here. Does that make sense?
No.
E over 3 square.
Oh, okay. I see it. Yeah, no, I see it. At least for E, I can see it. Okay, so because you got E.
Oh, because it goes to 1. Oh, wait.
Because when you put two E together, then you get T to the N, no matter what. So T to the outside, and you made it N to the negative 1. Yeah, because when you combine them, you both E to the 1, E to the.
What's the common ratio here? Is that okay?
You know, like soft multiply?
No.
Yeah.
Okay, what is 1 actually?
No, I got the right answer.
Oh, we multiply by 3 to even.
I thought it was smart.
Oh, and it brings
I'm not. Yeah, I'll give it a minus 1. What do you mean? Putting like but yeah.
that makes sense.
I manipulate it to a format where it's a to the n minus 1 or a r to the n minus 1 in this case because I start n equal to 1.
How do you get that to e to the n over 2 to the n equal to e over 3 to the n minus 1? Like, what's like the...
Can we just write it all?
What do you mean?
Because I got e to the n times 3 to the negative n So I did E to the. I don't know what I did. Let me go through it.
Where did you? I don't. Yeah, why do you have to do all that? Like,
I just went right up to the A to the N arm N minus 1. You can write out the format, yes. You get the same answer, yes.
eventually, I don't think we'll have it.
Well, okay, actually, would I be able to sit? I'm off, but like, am I able to, like, give her any? Yeah, please. And then it's off my.
Number one.
Okay, all of you.